All right, Dr. Hines here. I'm going to move on to the next part of the video series here. We had that fun entertainment of the disappearing string that was on Dr. C's sleeve. And so now we have another sleeve issue right here, possibly. We're going to find out when we do this. But let's kind of look at the procedure. What I'm going to basically accomplish is I'm going to measure out some hydrochloric acid into a small beaker. The exact volume is not necessarily critical. And then I'm going to add it to a eudiometer tube, which I'm going to show you in just a minute. And then I'm also going to fill it up with some water and insert the magnesium coil. And actually, I think when I look at this, I'm going to get through all these 8 steps right here. So this is how it's going to go down. So, you know, when you're measuring out liquids, I'm sure we've probably talked about this, but it's much easier to pour the liquid into a beaker and then use the beaker to pour it into some other type of measuring device. So I've got 6M, hopefully you know what M stands for here, and I need roughly about 10 milliliters, so I just pour in maybe just a little bit extra. So I've got my 6M acid, and now it makes it much more convenient for me to pour it in the graduated cylinder, and I'm trying to achieve 10, or pretty close. All right, can I get it? Can I get it? Drop, drop, drop. Ooh, I'm gonna stop right there. You can look at the video, hopefully see what that meniscus is saying on there. I think we're probably close enough for what we wanna do. Anyway, we've got the hydrochloric acid measured out. And this is what we call the eudiometer tube, all right? We're gonna be generating gas, and we basically wanna be able to measure the volume of the gas. You know, this looks an awful lot like a burette. I mean, you got all those little markings on there, and the only thing that makes it different than a burette is that one end of this is actually closed, and only the other end is actually open. So what I'm gonna do is I'm gonna get the acid in here first. That's what the directions tell me to do. And no, I'm not gonna try to do that. Not gonna try to do that. Nope, you shouldn't be trying to do that. We've got these little liquid funnels. That's what we have these things for, okay? Look, beautiful, all right? Now I can pour this in here very carefully. And you know, I don't wanna slop it on the floor, don't wanna do the tabletop and all that kind of stuff here. So when I do it, just to kind of be careful, I'm actually going to kind of do it over the water trough, just in case I do spill a little bit here. I'm not really worried about that, okay? All right, so I've got my graduated cylinder with 10 milliliters in it, and basically I'm just gonna pour it in here. Just gonna pour it in there. Nothing really special about it. Kind of thump it a little bit here, maybe get whatever droplet out of the stem of the funnel. And we are good with acid in here. Now the next part of the procedure is that we've got to fill the rest of the way up with some water. And I don't want to disturb the acid layer that's down here on the bottom, okay? There's going to be some mixing that will occur, but I don't want the mixing to happen just yet. Not that I can't prevent it 100%, but I'm going to try to minimize the amount of mixing of water and the hydrochloric acid. So what I'm going to do is I'm going to lean the eudiometer tube over like this, and I'm just going to kind of very carefully, I'm just going to squirt some distilled water in here. And you'll probably see a little bit of mixing going on, but not a lot. And so the objective is to kind of get enough water in here whereby there's a layer of water on the top. And then once I get a layer of water on the top, I don't necessarily have to be as careful anymore, because now I've got a protective layer, so to speak. So I'm gonna go ahead and just do this vertical now. I'm just squirting some distilled water in here. I wanna fill it all the way up, and you can see it takes a few minutes here. Hopefully you've got enough strength in your wrist to squeeze a water bottle for 30 minutes, right? That's how long it's going to take to fill this thing up. Not really, but See, one squeeze. One squeeze, I'm gonna get this thing filled up. I'm gonna test y'all's hand strength here. I'm still on one squeeze. One squeeze. I'm not sucking any air up into my squirt bottle just yet. And still one squeeze. I'm gonna come over here just in case I spill any. And what's really has to happen here is that this eudiometer tube has to be filled to the brim. In fact, it's gonna be overfilled a little bit. And all right, you see how it's overfilled right there? All right. Now, the next part of the lab is that we've got to get that magnesium in here, and it's got to get down in the tube, and that little rubber stopper has to be able to hold it in there. So, sometimes this can be kind of a problem here. Let's see, get a close-up of this magnesium. Actually, I'm gonna grab this string here by a little bit longer length. All right. All right, back and forth. Watch you go back and forth. Are you getting sleepy? Okay, so, man, it's floating. It's supposed to be higher density than water. What's the deal with this here? I'm gonna just, hopefully it'll just dangle here just a little bit. And I'm gonna poke it with a stirring rod. Well, what is this called right here? Why is it floating on top? Okay, you guys probably gonna talk about that in the intermolecular forces section. What is that called when it floats on the top? No, not because it's a lower density. Yeah, I'm gonna poke that down in there a little bit more. Okay, so the magnesium's in there now. It is in there. And you see how water's overflowing? And I'm even gonna squirt even more water in here. And not only that, but let's see, air bubbles. No. Yeah, we don't want any air bubbles in here. I'm seeing a few little air bubbles in here. This is where I'm seeing here. I'm gonna kind of tap that a little bit. Again, because we're gonna be making some gas. And you know what, I'm trying the best I can. There's still a little bit of air bubble in there, so this ain't gonna be a perfect result, but we're gonna see how close we get. Gonna get some water here in the top again. It's ready to overflow. In theory, I don't want any gas in this tube. So maybe you might notice that this little rubber stopper has a hole in it. So what's gonna happen when I mash this down in there? Water's gonna come out the hole. We're basically just guaranteeing that there's no air trapped inside here. So we put that on there. You see that there's water kind of coming out the top, and we're almost ready to go. All right, this is the most difficult part of the lab. Dr. C and I have some disagreement as to whether I'm gonna get my sleeves wet when I do this, and I assured Dr. C that I could do this without getting my sleeves wet. So I'm gonna put my finger over the opening on the stopper right here. I don't want anything leaking out. I don't want any air getting in here. And now I'm gonna flip this upside down. I'm gonna put it underneath the water in my water, to get a close-up of that sleeve. You better get a close-up of that sleeve there. The sleeve is not touching the water. And now I'm just gonna lift my index finger off of there, and I'm gonna leave it in the clamp. And now I kind of want you to see if we can get a close-up of that. Look at that hydrochloric acid. What is it doing? It looks like to me the hydrochloric acid is going to the bottom of the tube. And why would it do that? Why would the hydrochloric acid fall to the bottom of the tube like that? Yeah, in first semester chemistry, we talked about that concept. And more importantly, I'm gonna try to lift this. Oh, no, actually, my bad. I don't want to lift it up too much. I'm just gonna let it sit here. Just let it sit. You see all that fizzing going on right there? That is the production of hydrogen gas. Okay, HCl reacting with magnesium makes hydrogen gas. And you might even have to write a balanced chemical reaction for your lab report. Depends upon what your instructor wants you to do. But you can see it making hydrogen gas. All right. And it takes a few minutes for this to happen, so we might pause the video and then come back to the very end of this.